So first, let's analyze the denominators, right? Let's analyze the entire fraction. What's the degree of the denominator? So the degree of the numerator first. So the degree of the numerator is 1. What's the degree of the denominator? So this one, the degree of this is going to be 2, right? Because it is a linear factor, and that linear factor is raised to the power 2, right? So 1 times 2, that will be 2, and the degree of this one is just 1. So at the end, the degree of the denominator is 3. So the degree of the denominator is also 3. Then how do we make sure that we are, do we need to do long division or not? We don't need to do it because this is a how do you call it, a rational function, right? Proper rational function, not the improper one. So no need for any long division. So now the next step is now to analyze the denominator. The denominator, are they factorized already? Yes, they are already in factored form. So this one is how you have a linear factor here and then a repeated factor here, right? So that's what we realize, right? Because a factor is raised to a power greater than 1, then that's a repeated factor. So we need to approach them in that manner. Okay, so to that, in that case, now let's start. So let's rewrite this 3x plus 5 all over x minus 1 multiplying x plus 2 squared. This one should be equal to, so the linear factor as a denominator will be x minus 1, right? Then the next one will be a repeated factor. And then for a repeated factor, we say that we need to write that repeated factor the number of times that appear as separate. So this s plus 2 all squared. This s plus 2 all to the power 1, right? And this s plus 2 all to the power 2. So repeated factor, that's how they work. Each of them takes the denominator of every fraction, and then we start from the power 1, power 2, power 3, power 4, power 5, power 6. So if this one was to power 6, we should have continued. But because it's just to power 2, we are staying 1 and 2. So repeated factor side is also sorted, and the linear factor side also that is sorted. Now let's focus on their numerators. For the numerators, you know that linear factor, the numerator is just a, right? It's just one constant. So it's just a constant a that we don't know, we have to find. For this one too, is a repeated factor, and then the numerator of a linear factor that is repeated is also going to be a b, because inside it is a linear factor, and that linear factor is just to the power 1. So the numerator of linear factor is just b. This one, the numerator of a linear factor is also a linear factor, right? Inside, I mean inside it before it is squared, right? It is a linear factor that is squared, right? So because it's a linear factor, and we know that for numerator of linear factors, they're just going to be constant c, a constant c. Why am I writing c here? You have used a already, you have used b already, you have used c already. So this is the sample for that. Now let's continue. Now with that, we need to factorize or multiply both sides, right? So let me say multiply through by, we are going to multiply through by the entire numerator that we have here. So s plus 2 all squared. So if you multiply through with that, we are supposed to have just this one, the whole numerator will be cancelled. So you have 3x plus 5 here, which will be equal to, so if we use it to multiply this, only this will simplify this, right? So we'll have a to multiply x plus 2 all squared, plus this b will also multiply x minus 1 multiplying x plus 2, plus c is going to multiply x minus 1. Okay, so we have been using cover up rule so far, but right now let's use the completion of square method. Right, we are going to do the expansion method. So first, let's expand this and group like terms. So I'm going to shift this one equal to over here a bit, a into bracket. So if you expand this square thing, you're going to have s squared plus 4x plus 4. So if you expand this, you are going to have this. If you expand s plus 2 all squared, you are going to have this, and a is still multiplying that, so we'll keep that, plus b into bracket This will multiply this, right? This time it is that is going to be x squared, right? This times this, that will be 2x, right? X times this, that will be plus 2x. This times this is going to be minus x. This times this is negative 2 plus, as for the c, for now we keep it like that because it's okay. Now let's continue. So we are having um a to multiply x squared plus 4x plus 4 plus b into bracket x squared plus x minus 2. Okay, so I'm just simplifying like terms inside here, plus c into bracket x minus 1. So we have a good point there. Now we need to expand and have a group like terms now. So with the constant. So this one is going to give me a x squared plus 4ax plus 4a. Now let's go to the b, plus bx squared plus bx minus 2b plus, expand this, we are going to have cx minus c. So we are fine. So now let me continue. Now let's look at grouping like terms. So we have s squared here, right? S squared term here. We have another s squared term here. So let's group s squared terms together. So it's going to give us the coefficients are a plus b. The two of them are multiplying s squared. So we have sorted s squared terms. So the next thing is to go focus on terms that contain x. So this term contain x. This is an x term. This is an x term. This is just a term in x as well, right? And this is also a term in x as well. So we focus on those ones. So now what are their coefficients? So plus into bracket. So I have 4a, right? 4a plus b from here plus c from here, right? All is multiplying x. Now we focus on the constants. The constants are, so we have 4a as the first one plus negative 2b, so it's going to be minus 2b, right? So let me clean this and do minus 2b, and the c is left with c minus c. So those are the constant terms. Okay, now we have this, now we have these terms. Now let's bring back what we had. So on this side we were comparing 3x plus 5, right? So let's bring back that 3x plus 5 here and compare both sides. So I'm going to have 3x plus 5 be equal to, now, a plus b s squared plus into bracket 4a plus b plus c multiplying x plus 4a minus 2b minus c. So you can see that now let's compare both sides. Over here, do we have any s squared on the left? So this is the left hand side and the other side is the right hand side. So this side is the right hand side, right? So let's say comparing coefficients on both sides, basically on both sides. So let's see if we will get what we want. So over here, right, the first coefficient that we want to compare a term in s squared. Do we have a term in s squared over here? No. If it is not there, it means that it's going to be 0. So it means that a plus b, that is coming from a plus b s squared, right? That coefficient, if you compare it on the other side, which is the left hand side, we don't have s squared there, meaning that that coefficient could have been 0. So this is the first one, right? So we can write this in such a way that, yes, so that's the first one. The another one is, let's compare this coefficient. The coefficient terms in x term. So x term is here. We also have s term, which is 3. is the coefficient attached to it, and then this is the coefficient you have attached to the x over here. So let's compare both sides. It means that if you have 4a together, 4a plus b plus c, they are going to be compared to 3 on the other side. That's 3 on this side, right? So we are okay with that. Now let's compare the constants. The constants, we have 4a minus 2b minus c is going to be compared to 5, because 5 is the other constant on the other side. Okay, so now that we have this, what we're going to do is that we need to replace stuff, right? So I can say that from here, b is equal to negative a, because I'm going to send the a to this side. So b is equal to negative a. So if I put that b value inside here, what am I going to have? So if I put that b value inside here, we are going to have, putting b value inside here, we have 4a. b is negative a now, so it's negative a plus c equals to 3, right? That will give us this, and this will give me something like 3a plus c equals to 3. So basically this is what I have over here. Now for this one, so let me put the value of b inside here as well. It's going to be 4a minus 2 times, so minus 2 times negative a, because b is now negative a here from this particular first equation, right? Minus c equals to 5. So if you do that, what are we going to have? I'm going to have 2a, right? Definitely. Let me see. So 4a plus 2a, that will be going to be 6a, right? 6a here minus c is going to be equal to 5. So solving this simultaneously, so definitely the two equations that we have is 3a plus c equals to 3, and 6a minus c equals to 5. So we need to find the value of a, right? So if you group these two things together, this and this will give you 9a, this will give you 0 equals to 8. So we can see that a is equal to 8 over 9. This is the value for a. So now that we know the value for a, we can use it to find the value of b, right? Of c, for example. So we already know that yeah, for b we can find the value for b. This is going to imply that since b is equal to negative a, b is equal to negative a already, this will mean that b is equal to negative 8 over 9. So this is the value for b. Now let's find the value for c. So let's take one of these equation. We have 3a plus c equals to 3. So I'm picking this particular equation now that I know the value of a already. So I'm going to put that somewhere. So I know that c will be equal to 3 minus 3a. So this will be equal to 3 into bracket 1 minus a. I'm just factorizing 3 out. Here, over here, we don't do anything, we just solve the math. So I have 3 into bracket 1 minus 8 over 9, because the value of a is 8 over 9. Then we have 3 into bracket so 9 minus 1, that will be 1 over 9, right? So that 1 over 9 will multiply this. Then we have 1 over 3. 1 over 3. So the value of c is equal to this. So at the end of the day, our expression that we wrote here, right, we need to replace the values back. Where did you start from? We started from this, right? We started from this whole thing. Right? We need to write this thing back and put the values of a and b back in it. So I'm going to do, so we have 3x plus 5 all over x minus 1 to multiply x plus 2 all squared. This is going to be equal to a, right? The value of a is 8 over 9, so it's 8 over 9 over x minus 1 plus the value of b is negative 8 over 9. So negative 8 over 9 going to multiply x plus 2, right? Now the value for c plus 1 over 3 all over s plus 2 all squared. Can further expand it to make it clearer and finally have 3x plus 5 all over x minus 1 on this side, s plus 2 all squared. This is equal to 8 over 9 multiplying x minus 1 minus 8 over 9 multiplying x plus 2 plus 1 over 3 into bracket x plus 2 all squared. Yeah, so this is the final answer for what we had to solve, right? Yeah, so this is looking nasty. Let me just leave my stuff like that. So now, so yeah, so let me just do this. This is the final answer that we need to get. Okay,